Hello everyone, welcome back to Clear the Air. It's good to see you all again, even though I can't really see you, but you know what I mean. It's been a while just because school has been very hectic. We're in week 11 of 12 weeks, so wrapping up courses, finishing assignments, and getting ready for exams. I've been putting out some podcasts in the meantime, so if you haven't checked out those yet, I did some really interesting new topics about ecocentrism, which was based on an article I read for a course, so I really recommend that you check that out, and an interview with a friend named Michelle, and we talk about eco-activism, how to get involved in political activism, and other things as a young person. Check those out in the description below. Anyways, today I wanted to talk to you about something that is very relevant at the moment. If you can tell, my face is a little bit red, and that's because I just came back from a walk and it's a little bit snowy outside. So yes, it is a little bit snowy outside. It's our first major snowfall of the year. We had about 10 centimeters here. And this brought up a topic that I've debated with people quite often recently, and it is, if there's snow, climate change isn't real because we wouldn't have snow. Let me start off with no. False. I'm going to explain why that's false today for anybody who doesn't really understand the science behind climate change and the difference between climate change and weather, because that's really what we're seeing and how it's relevant to climate change, the implications of that for the future. The difference between climate and weather is based on the time period that you're looking at. So weather is more a short-term period. You're looking at hours, days, maybe even up to 2 weeks. That is considered a short-term forecast of the weather. And so that encompasses things related to like snow and precipitation, sunlight, all that type of stuff. But what matters is you are looking at it at a short period of time based on different fluctuations in the Earth's systems related to wind and precipitation and things like that. But it's not long term. Long term is where climate comes in. Climate is the seasonal average over a long period. So you're looking more at like years, decades, even up to centuries. We are trying to predict centuries from now what the climate is going to look like. And that is taking the average of the weather that we have been seeing. So looking at the average over, typically for statistics, 30 years. So that's sort of the benchmark for when you're looking at climate and making climate predictions. You're looking at averages over 30 years. And so this distinction between weather and climate is really important because when you look outside on a day like today where, we have like 10 centimeters of snow, and then people say, see, climate change isn't real, we're still getting snow. No, we got snow today, but when you look at over whatever a span is, let's say the past 10 years, and then you compare that to the 10 years prior to that, there were probably less snow days in this current 10-year period than there were in the 10-year period before that, and the 10-year period even before then, which was 20 years ago. And 30 years ago, there's probably more snow than there is now, more frequent snow days, more total amount of snow. Because what we are seeing as temperatures warm, which is one of the main things that's happening with climate change, is that we are getting less snow. It might be coming in a different form of precipitation, like rainfall. So we might get less snow, but we will get more rainfall because temperatures are warmer, and so in the sky, if it's too warm, it's not going to make snow, it's going to make rain. So weather is sort of a reflection of the current climate and what's going on. And weather is going to change as a result of the climate in years to come. So our weather right now looks like we got a lot of snow today, but it's been, ranging between 0 degrees to 5 degrees for the past week or so. But perhaps 10, 15, 20 years down the road, when you look at the same period, today I am recording this on November 23rd, so let's say if you look at November 23rd to November 30th, 10, 15 years down the road, temperatures might actually range between something like 2 degrees and 8 degrees, or 5 degrees and 10 degrees, and so that overall average has gotten warmer, and so we're not going to see snow days like we have seen today if that average has changed. And those are the type of weather patterns that we are seeing as a result of the overall climate changing. So now that we know the difference between weather and climate, you'll be smart and not say things like, oh, well, climate change isn't real because we got this crazy snowstorm, or, we had an ice storm 3 times this year or something, or whatever it may be. What we are now going to talk about is how that's related to climate change, and specifically how climate patterns are related to climate change. So one of the things about climate change is that, yes, there are natural forms of climate change, and that is related to the Earth's orbit. It could be oceanic circulation, it could be volcanic activity, it can be the position of the Earth relative to the sun. Those are all natural influences over the Earth's climate. And so, yes, those things are naturally going to happen, but the overall impact that those forces have on our climate is very minimal in comparison to another force that has been a lot more powerful since the Industrial Revolution around the 18th and 19th century, and especially since around the 1980s, we've been seeing a big shift, and that is anthropogenic climate change, or human-induced climate change. And so this is a result of human actions, burning more fossil fuels like coal and gas and oil, doing these different activities that produce a lot of carbon dioxide, because what carbon dioxide does is it gets into our atmosphere, and it is almost like a really thick gas. And so it makes our atmosphere really thick. And when sunlight comes into our atmosphere from the Earth, some of that will bounce back off the Earth's surface back into the atmosphere, but some will get caught in our orbit or in our atmosphere, and that allows the Earth to be warmer than the surroundings, than outside our atmosphere, and it's usually around 33 degrees or so. Those influences allow us to be warmer within the Earth's atmosphere than outside of it. But what we are seeing as we get more carbon dioxide in our atmosphere, it's making it really hard for that energy from the sun to bounce back off the Earth's surface out of the atmosphere. It keeps it trapped in the atmosphere more. And so more energy in our atmosphere means the Earth gets warmer. And more emissions being produced means it's harder and harder for the energy of the sun to escape. And so things get really hot really fast. That's what we're seeing. And when I say really fast, I don't mean like today is going to be 0 degrees and then tomorrow's going to be 30, although we have had some of those really crazy days in the past year, I will say, but that's not what I'm trying to say. What I'm trying to say is that the overall averages, if you were to look at a graph, let's say of the 1900s to now, you're going to see average temperatures go like this. And there's going to be a nice, what's it called? Sigmoid curve? Exponential. It's not exponential. I'm brain farting. I haven't taken math since high school. So what we are seeing are temperatures rising since the 1900s and this overall average. And there is scientific data to prove this. This is not a hoax. This is not an opinion. This is scientific fact. We have the data. We have the diagrams. We can prove that the temperature has undeniably been changing. It's been increasing around the world, and it is largely due to anthropogenic climate change, because these temperatures have also been mapped with just natural climate change. So things like volcanic activity, oceanic circulation, that type of stuff, because some of those natural forces will actually help cool down the Earth too. And so scientists have been able to map what natural climate change would do to our temperatures versus what anthropogenic climate change has done to our temperatures. And it is very clear that the two are different, and that without the contribution of greenhouse gases caused by human actions, the temperature would not be rising as rapidly as it is, and things in the world would not be as detrimental as they currently are. If you're looking at what we have going on now, what's been happening the past couple hundred of years, and what the likelihood future scenario is, it's not looking too hot, honestly. In a business as usual scenario, so by that I mean if we don't try to cut down our greenhouse gas emissions, if we're not trying to reduce our carbon footprint on the planet, then things are likely going to increase a lot over the next couple of years compared to 1980 temperatures. If we follow this business as usual trajectory, by the 2050 range, we are going to hit about 2 degrees higher than what the average would be from 1980. So for instance, on November 23rd, 1980, maybe it was, I don't know, like -5 degrees on November 23rd. But in 2050, that could actually be -3 degrees. And then the projection for that business as usual model is that by 2100, we will be about 4 degrees higher than 1980 levels. And so instead of -5 degrees, it will be -1 degree. Or if you're looking at the summer, instead of a day, let's say in August, being 30 degrees, it's actually going to be 34 degrees on average. Those numbers might not seem like that big of a deal when you're looking at it just as a day-to-day forecast. Like, yeah, -1 in comparison to -5 sounds great. But if you're looking at it in a global picture, that's not great at all, especially for really vulnerable areas of the earth that are very sensitive to changes in temperature because of the way their ecosystems are structured. In particular, if you're looking at higher latitudes, such as polar regions, they are being unprecedentedly impacted by climate change right now. We are seeing glaciers melting, sea ice melting, and of course you're seeing in the media how polar bears are being impacted by that. But these regions are being unequally impacted by climate change in comparison to other regions just because of their reliance on colder temperatures. And so when temperatures are no longer able to support sea ice year-round, or the certain periods that they usually do, things are going to not look the same. And chances are that by 2100, if we're still following this same scenario, there might not even be any sea ice left, or very little sea ice left. And not only is that going to impact those ecosystems, but when you think about it, there is a lot of fresh water stored in sea ice and in glaciers. And what happens to that water when the glaciers melt? It goes into our oceans. And so we are seeing things like sea level rise, and that's another big problem of climate change. And so you're seeing these small island nations literally disappearing because ocean waters are rising and drowning their entire communities. And so not only is this leading to climate refugees because people have to leave their islands because they are disappearing, but we are seeing the loss of entire communities, entire structures, millions and billions of dollars of worth of infrastructure lost as a result of climate change. And even if you are not seeing the impacts of climate change right now, it does have this ripple down effect where it first will affect the most vulnerable communities, which then begin to cascade down and affect others. So what I'm trying to say is that climate change is happening. It's not really avoidable at this stage in where we are because of the actions of the past few decades, especially have been accelerating climate change, and climate change has a delayed effect. So we aren't seeing the impacts of present day. So maybe the flights, let's say you took like 20 flights in 2019, you're not seeing the impacts of that immediately. What we are seeing are the impacts of maybe the early 2000s or the 1990s or the 1980s right now. And so the impacts of your 2019 flights probably won't be felt for another decade or so. And so what is happening right now is not really avoidable just because of this delayed effect, and we are experiencing impacts from actions taken decades ago. But going forward, we are able to mitigate our impact if we start taking more responsible action and we take active steps to reduce our carbon footprints. It's important that everybody in the world is taking these actions to reduce their carbon footprint, because while climate change may not directly impact them, maybe you don't live in these northern latitudes where sea ice is melting, or maybe you're not on a small island nation. Climate change is also predicted to impact places around the world. Places who usually are a wet climate will be even wetter probably, and places that are dry will get even drier, and there will be more droughts. And resources that come from these vulnerable places, such as small islands or polar regions or dry, arid regions, we won't have those resources anymore. And so for those economies and those communities like ours that are dependent on those resources, they will no longer be available. So long story short, everyone is going to be impacted by climate change, and so it is up to everyone to try and take actions in their own ways to reduce their carbon footprint, especially for very wealthy, very developed countries like Canada and the United States and other countries like that, where we are unfortunately responsible for a lot of the greenhouse gas emissions that are currently in the atmosphere. While there are other nations that are producing more emissions as of now, or they are seen to be greater contributors to climate change going forward, such as industrializing nations like China and India and others like that, it is still up to everybody to reduce your greenhouse gas emissions in whatever capacity you have. And so to do that, we will need political change, we will need action from our governments, we will need financial incentives, and we will need to take action into our own hands. It really is an all-encompassing issue, And there are ways that you can start taking action in your own life right now, even if your government isn't that supportive of it, even if there aren't policies in place in your community to promote climate action, you can take action. And I am going to provide some of my resources to show you how to take climate action in your own life in the description below. So I encourage you to check those out. So to summarize all the words that have come out of my mouth, weather is different from climate change, and just because it's snowing right now doesn't mean that climate change isn't happening, because it is. Climate change will impact everyone everywhere, although it will unequally be distributed, and as of right now, just because you don't feel the impacts doesn't mean that they won't happen. And then third, everybody is responsible for taking climate action because this is a global movement because of the delayed effect of climate change. The actions we take right now will influence how we are able to live in the future. And if you want a prosperous future, you need to start considering what your actions are doing right now and how that will impact you in the future and future generations. That is all for this YouTube video. I hope you enjoyed and learned a little bit about climate change. Let me know what you are doing to take climate action in your own life in the comments below. I love to hear what you're doing, and I love to get feedback about my videos. Also, remember to check out my podcast and my blog where I've been posting actively, and follow me on social media. All of those links are in the description below. So thank you again so much for tuning in, and I will see you in the next video. This is Jenna signing off. Until next time.